Okay, so I am going to show you how to revolve around a line that is not an x-axis. Okay, for example, in the first one, you'll see we're revolving around the line y equals 1. The key thing you need to know, it is the radius is what changes. Okay, recall that when we revolve around the x-axis, it's pi, your integral from a to b, f of x squared dx. F of x is your radius. And when we revolve around a line other than the x-axis, it is your radius that changes. Okay, so start with a picture. We have 2 minus x squared, looks like this, and g of x equals 1, which looks like this. So it's this region, okay? We're revolving around the line y equals 1, so we're revolving around this line. All right, you're revolving right there. So this is your radius. We get that radius by doing the top, right, the whole thing. So that's 2 minus x squared minus 1. That gives us this radius that's left over. Okay, so that means my radius is now 2 minus 1 is 1 minus x squared. So when I do the volume, it's always pi. Now, my bounds, I need to find when 2 minus x squared equals 1. So x squared equals 1. So x will be plus or minus 1. Okay, so negative 1 and positive 1. And then my radius squared. So 1 minus x squared dx. That's how you set it up. Okay, number 2. I'm just going to do the setup on these. My answer key will be done out and will be posted on Schoology. I'm just teaching you the setup right now. Okay. All right, the next one. The region bounded by root x, y equals 0, which is the x-axis, and x equals 4. Around the line y equals 4. All right, so when x equals 4, y is 2. So we're revolving around this line up here. Okay, so I should put that in a different color. Okay, so we're revolving around this line. All right, in this case, you have a top and a bottom. All right, so think about when we rotated when there was a hole, right? And we did the top squared minus the bottom squared. That is the same situation here. Okay, so we're gonna do, okay, so the top is this whole thing. That distance is 4. So really you're gonna rotate 4. So remember, like when you rotate this, I'm gonna run into a different problem here. Okay, so when you rotate that, it's coming up here, right? So you're coming up here and then you're rotating. So that's your hole in the middle. Okay, so you do have to, I can't color it in, I'll be coloring over that problem, but you're going to take this whole thing. So that initial radius is just 4, right? So you have pi, the integral, so we're going from 0 to 4. So the first one is 4. You're going to rotate that. So you integrate that. Now your next one, let me do a different color here. This piece right here. How do we get that length? Well, this is 4. This is root x. So if I do 4 minus root x, I have that radius left over. So I'm going to subtract out, this one is 4 minus root x squared. Okay, let that sink in for a minute. Okay, so again, we did the entire thing, right? So that's your 4. That was this color. We did 4. We rotated that because there's a hole, right? So this one, you want to keep in mind, there's a hole here between the region. So this was your region down here, right? There's a hole between your region and the line of revolution, which is why we have a minus. okay? Now, the whole thing is 4. That's this piece. The other piece, I'm going to show you one more time. We'll do blue this time. All right, so this distance, well, you can't see that one. Okay, let me do orange. This distance right here, okay, think about how you get that. We do 4 minus root x. That gives you that distance left over. That's where the 4 minus root x comes from, okay? And we're subtracting out that region. Okay, hopefully you're okay with that. All right, the next one. Find the volume of the solid formed by revolving the region bounded by y equals x. So y equals x, y equals 3, and x equals 0, which is our y-axis. So this region right here, we're revolving around the line y equals 4. So we're revolving around y equals 4. Okay, so again on this one, I'm not giving myself enough room to rotate these. Okay, so this one looks like this. There's a hole again. Okay, there's a hole there. So think about it like that. I don't know what that shape is. Okay, so how do we do that? So we think first of the larger region, right? So this piece is going to be tricky because it's not just top minus bottom here. You've got to do the bigger region minus the smaller region. So the bigger region is this one right here. Okay. So remember, this was y equals x. So that bigger region, I'm going to do 4 minus x, right? The whole thing is 4 minus x gives you that radius left over. So 4 minus x is your first radius. Okay. And then, so, gosh, I didn't even start. Okay, hold on. Pi, your integral. What are your bounds here? You have, excuse me, y equals 3 and y equals x. So therefore your bounds are from 0 to 3. All right, so we've got the 4 minus x gives you the bigger radius, so that's squared, minus, now the smaller radius is this piece right here. So what is that? 4 minus 3 gives you that radius. So 4 minus 3. Yes, that's just 1. Yes, you can write 1. I just did that so you could see it. Okay. I hope this is making sense. All right, last one. So we have 4 minus x squared, y equals 0, so that's your x-axis. Oh, so that's the whole region. We revolved around the line y equals -1. So this is y equals -1. We're rotating around that line. So what does that look like? This is going to come down here, this, and then there's like this hole in the middle. I don't know. I don't know what that shape is. Okay, so anyways, there's a hole directly down the middle. I guess that would be more like a bagel or a donut, right? If you revolve it and then a hole straight out of the middle. All right, anyways, so you're revolving around this line. So now it is the top. Now, so when you're doing this top one, right, it's the top minus this. Bear with me. So if you do that top, that's 4 minus x squared minus this piece becomes +1, right? Because it's minus a -1, and that's what it is. This is my x-axis right here. So this is your 4 minus x squared plus 1 gives you that radius. Okay, so volume, pi, the integral. Oh boy, the bounds. I should always find the bounds first. I don't. Okay, 4 minus x squared and y equals 0. Oh, so that's 2 and -2, right? 4 minus x squared equals 0. So x is plus or minus 2. So negative 2 to 2. Okay, so this is your first radius. So that is 5 minus x squared. Rotate that. And then you've got, here's the second one is this. This is your hole, right? The radius of your hole is 1. So minus 1 squared. Okay, now if you want to keep thinking about that as top minus bottom, it's 0 minus a negative 1. So that's why it's 1. Okay. Hopefully the setup of all of those makes sense. And you can start to try your own. All right. This is one that this is your when. Okay. So when these ones are when your line of revolution is above the region. Okay, that's these two. And these two on the right is when line of revolution is below the region. Okay, so when it's above, this is kind of your overall, this is your formula you're going to take. All right, so we have the volume, pi integral, we're going from A to B. Now, when it's above like this and it meets the x-axis, you've got to do this whole thing, right? The whole thing, and then we subtract out the middle because there's a hole. So the whole thing is c. So you're going to do c squared minus this piece. All right, and we're going to call this f of x. Okay, so this piece, now, this piece right here is c minus the function. So c minus the function squared dx. That's when there's a hole. Okay, and remember, c is your line of revolution. Okay, now, in the one below that, this one, we have the line is above, but now you've got two functions. Okay, so volume pi from A to B. So you've got to do the outside one first. Now, how do we get that? That's c minus g of x. So this is c minus g of x gives you that radius. So c minus g of x, rotate that, and then minus, now you've got to do this one. What is that one? C minus f of x. Square that. That's how you get it. Okay, so a lot of these, if you're struggling, you want to think C is your line, G of X. So these are all when your line of revolution is above, okay? Line minus, this is the bottom function, and then line minus the top function, okay? If you're one that likes to have that. All right, the other side. This is when the line of revolution is below the region, okay? So looking at this one, you've got to do the whole thing, all right? So volume pi, your integral from A to B. You're going to do, I'm going to call that f of x. Okay, so f of x minus the line. If the line is below the x-axis, that's going to be minus a negative, so it ends up being plus. Okay, so you can write that however you want. I like to always think about it as it's the same, so I'm going to do f of x minus the line. Okay, so that's That's this whole thing. Okay, or you can have that f of x plus c if you want. C in this case happens to be negative. All right, and then the second piece of that is minus, now you've got to take this whole out. What is that whole? Just your line. So minus c squared. Okay. And then finally this one that has two functions. You got to take the top one first. Okay. Now, that top one, again, pi from a to b. F of x is this distance right here minus the line. So you're going to do f of x minus c. And then g of x minus c. Okay, so g of x minus a negative c becomes plus c. Yes, so it all depends on how you want to look at that. I always do minus because you don't know it's not always going to be a negative. Okay, and again with this one, if you look at this, when your line is below, so this is the difference between this two. This one, the line is above the region. When your line is below the region, okay, I can spell. When your line is below the region, in this line, I mean your line of revolution, okay? When your line is below, it's like you're gonna do your top minus the line, and then your bottom minus the line. The line is your C value, all right? So hopefully that all makes sense.